Hi, my name is Mohamad Haiqal bin Mohamad Nazri. My metric note card number is CF220084. I am from section 5. Today I will explaining about the differentiation between geotechnical and geophysical technique. For the definition of the geotechnical and geophysical, both geotechnical and geophysical technique play critical roles in site investigation. Geotechnical methods provide precise, design-oriented data, making them essential for structural design. On the other hand, geophysical methods offer broad, quick insight into subsurface which are useful for reconnaissance and identifying areas of interest. A combination of both in techniques ensure true site investigation, minimizing risk and optimizing design. Geotechnical techniques. Geotechnical techniques involve direct interaction with the soil, rocks, or groundwater to gather engineering properties. This helps determine whether the site can support structures safely and predict issues such as settlement, slope instability, or bearing capacity failure. Geotechnical techniques divide into five types. For the first type is drilling and sampling. Boreholes are drilled to extract samples, distribute or undistributed. Samples are tested in labs to determine parameters like soil density, moisture content, athabate limit, and shear strength. Next is standard penetration test. Standard penetration tests measure the resistance of soil to penetration by a split barrel sampler. It gives an estimate of soil density and strength. Third is cone penetration test. A cone is pushed into the ground to measure tip resistance and side friction, helping assess soil stratification and shear strength. Next is pilot test. Pilot test monitors the behavior of a pile under a test load to determine its bearing capacity. Lastly is prop Macintosh test. Prop Macintosh test is a lightweight prop test for shallow depth commonly used in a soft soil to determine its consistency or hardness. There are three advantages of geotechnical techniques. First is a high accuracy. It provides precise location specific data. Next is the design oriented. The test result directly support structural design, for example, determining allowable bearing capacity. Third is a direct analysis. Actual samples are obtained, enabling lab tests for properties like compressibility and permeability. Next, I will talk about the geophysical techniques. Geophysical techniques involve indirect methods that use the physical properties of the ground, like density, resistivity, and wave velocity, to infer subsurface conditions. These methods are non-invasive and are primarily used for site reconnaissance or to detect anomalies such as void, groundwater, or buried utilities. There are four types of geophysical techniques. For the first one is seismic method. This method analyzes how seismic waves travel through subsurface layer. Wave velocities help determine rock or soil types and depth. Reflection techniques are used to image deeper layers, while refraction is better for shallow investigation. Next is electrical resistivity tomography. Electrical resistivity tomography are introduced into the ground and the resistivity of the subsurface is measured. This is useful for detecting groundwater voids or soil stratifications. Next is ground penetrating radar. Ground penetrating radar use high frequency electromagnetic wave to detect object of change in material properties. GPR is often used for locating underground utilities or identifying subsurface voids. Next is a magnetic and electromagnetic surveys. This technique detect magnetic or electrical properties of materials that are helpful for identifying buried material objects or geological features such as faults. For the geophysical techniques, there are four advantages. For the first one is it is non-invasive because it is no drilling or excavation is required, making it ideal for sensitive or inaccessible areas. Next is a fast. It covers large areas relatively quickly compared to the geotechnical methods. Next is a cost effective. It is less expensive for preliminary surveys. Lastly, is a broad coverage. It provides an overview of subsurface conditions, identifying potential problems areas before more detailed investigation. For the conclusion, in practice, these two approaches often complement each other. For example, geophysical surveys are used to identify areas of interest, followed by targeted geotechnical investigation for more detailed analysis. That's all from me.